In this video, we're going to talk about the sodium-potassium pump. So in red is the cell membrane. Below that is the intracellular fluid, which is basically inside of the cell. And outside of that, we have the extracellular fluid, or the outside part of the cell. Now, the concentration of sodium ions outside of the cell is very high. The cell tries to keep the concentration of sodium ions low inside of the cell. And the reverse is true for potassium. The concentration of potassium outside of the cell is low, but the cell tries to maintain a high internal potassium concentration. So make sure you understand that. So the concentration of sodium ions in the cell is low, but the concentration of potassium ions inside the cell is high with respect to the extracellular fluid. Now, the first thing that happens in the sodium-potassium pump is that 3 sodium ions will enter the pump. In addition, energy is needed. So ATP is going to convert to ADP, and it's going to phosphorylate the pump. It's going to activate it. So it's going to transfer a phosphate group in the process. So right now we're going to have 3 sodium ions and a phosphate group. Now once the sodium ions enter, as well as the phosphate group, the protein changes shape. On the bottom, it closes. On the top, it's going to open, giving us the shape that we see here. Now, in the next step, the pump is going to lose affinity for the sodium ions. So the 3 sodium ions are going to leave. And this is going to maintain a high external concentration of sodium ions. Now, as the 3 sodium ions leave, 2 potassium ions will enter the pump. And I'm going to highlight that in purple. So here are the 2 potassium ions, and we still have a phosphate group. Now, the protein is going to lose affinity for the phosphate group at this point. So the phosphate group leaves, and then it undergoes a conformational change. The shape is going to change once more. So at the top of the protein pump, it's going to close, and at the bottom, it's going to open. So right now, what we have are 2 potassium ions in the pump. Now, after the protein pump changes shape, it's going to lose affinity for the potassium ions, causing the potassium ions to leave. And so they're going to maintain a high concentration inside the cell. At this point, the process is going to repeat itself. So the sodium ions that are inside of the cell, 3 of them are going to go back into the sodium-potassium pump. And the phosphate group, which will come from ATP, will re-enter the pump as well, repeating the entire cycle. So that's how the sodium-potassium pump works. So let's summarize what we've learned. As we said before, the concentration of sodium ions inside the cell is low. And the concentration of sodium ions outside of the cell is high. For every cycle of the sodium-potassium pump, 3 sodium ions are pumped across the membrane. So notice that the sodium ions are moving from a low concentration gradient to a high concentration gradient with the use of ATP energy. So this process of moving molecules or ions up the concentration gradient is known as active transport. So the sodium-potassium pump is an example of active transport. Now, as the 3 sodium ions move up the concentration gradient, two potassium ions are going to move in the opposite direction. So it's a 3-to-2 ratio. The concentration of potassium ions inside the cell, as we mentioned before, is high. And the concentration of potassium ions outside of the cell is low. So the potassium ions are also moving up against their concentration gradient. So that is an example of active transport, using energy to go against the concentration gradient, moving from a region of low concentration to a region of high concentration. So that's a basic review of how the sodium potassium pump works. Thanks again.